Hi and welcome. I'm trying to learn biochemistry. Today, inorganic acids, bases and salts, and after we've done it, we're going to do leg injury prevention training. And if you participate in the leg injury prevention training, then it's better at your risk. And this is part 2. When inorganic acids, bases or salts dissolve in water, they dissociate. Okay, now we want to go through the text and try to gather the informations together, which we're going to use in our presentation. Okay, acids, bases and salts can dissolve in water, and that is called dissociate. And that is that they are separating into ions and become surrounded by water molecules. Okay, when inorganic substances like acids, bases and salts are dissolving in water, they are dissociating. They dissociate, and by that process they are separating into ions, and the ions are then surrounded by water molecules. An acid is a substance that dissociates into one or more hydrogen ions and one or more anions. I think we should stay in possibility talking. An acid can dissociate into hydrogen ions? Or should we go from is a substance that let's stay in a possibility. An acid is a substance which can dissociate and could become when hydrogen ions with one or more hydrogen ions with one or more anions. Because H plus, and they are called then H plus, and this H plus is a single proton with one positive charge. An acid also is a proton donor. Is also because H plus is a single proton with one positive charge, it is a proton donor. And this H plus, this hydrogen ion, has a proton with a positive charge, it is a proton donor. A base is contrasting to it. It dissociates into one or more hydroxide ions. That is then OH minus and one or more cations. Because hydroxide ions have a strong attraction for protons, a base is a proton acceptor. Bases, for example, can dissociate into hydroxide ions, and they now are negative. So they are proton acceptors, they want protons. A salt, when dissolved in water, dissociates into cations and anions, neither of which is H plus or OH minus. In the body, okay, and the salts do not become positive or negative, like the positive hydrogen ions, H plus out of the acids, or out of the base coming hydroxide ions, which are negative, with cations. They are becoming anions and cations, and they are neither plus nor minus. These salts are in the human body important to carry electric currents. Ions flowing from one place to another to carry, and these salts are important in the human body to carry electric currents. That happens by ions from one place to another in the human body. Ions flowing from one place to another, especially in nerve and muscle tissue, and that happens in nerve and muscle tissue. The ions of salts also provide many essential chemical elements in intracellular and extracellular fluids such as blood, lymph, and the interstitial fluid of tissues. Maybe you're going to stay away from that sentence without telling an example. Next one is acids and bases react with one another to form salts. For example, acids and bases can react together to form salts. And there can be the reaction of hydrochloric acid, hydrochloric acid, together with potassium chloride, potassium hydroxide, and potassium hydroxide. Hydrochloric acid and potassium hydroxide. And that is the base. We had hydroxide ions, and the other thing was hydrogen ions. And we have hydrochloric. I don't know if it has something to do with each other. And they together making the salt potassium chloride and water. Okay, the reaction is the most complex one. We're having, for example, can there be hydrochloric acid, and the acid, and if it goes together with the base hydroxide, potassium hydroxide, potassium chloride, no, potassium hydroxide, then it can form potassium chloride. We had hydrochloric acid, hydrochloric, and the other thing is potassium chloric. So we're having 2 times chloric. Whatever, and it becomes potassium. So we're having hydrochloric acid and potassium hydroxide, and they're together making then potassium. What was it now? Chloride and water. Okay, here are the all informations. The informations are, we're going to call it like that, acids, bases, and salts in the human body. Acids was something in the introduction. Acids can, yes, they can dissolve in the human body, and that happens by a process called dissociate, and there the ions are get separated, and they have the water molecules around them. And there can be, for example, the acid hydrochloric acid. No, it's just an acid is a substance that dissociates into 1 or more hydrogen ions. Let's quote. And an acid is a substance which dissolves or dissociates into hydrogen ions. No, and they have into 1 or more hydrogen ions with 1 or more anions. And such a hydrogen ion consists out of a proton and an anion, just a proton, here only the proton, and proton, and therefore has a positive charge. It is now a proton donor. A base, for example, is something which dissociates into 1 or more hydroxide ion. A base is dissociating into a hydroxide ion. We had hydrogen ion and hydroxide ion now. And they have cations with them. And now such a base, such a hydroxide ion is negative, it is a proton acceptor. And they two can come together and building then a salt. But that comes later. First, the salt when dissolved in water. No, let's go with it. And they can now react together to form salts. And they can be hydrochloric acid, the acid, and the base potassium hydroxide. And when they react into they come together with salt, then potassium chloride and water. And now such salts can be dissolved in water. No, and they have now cations and anions, and they are neither positive nor negative, and they're able to make electrolysis, and they are now electrolytes. Is it something different? They are now electrolytes, and they are in the human body important to carry electrical currents, nerve impulses, or muscle tissue impulses. I don't think I'm able to say that now. We're going to do it the next time. That means we're going to come back, then we put it all together again, and then we're going to say. That means that was the biochemistry part. If you were here for biochemistry, you can go directly to the next part of biochemistry. If you stay here and participate in the leg injury prevention training, then it's better to risk. We're having a good and stable standing leg, and we're swinging the other foot to the side and in front. And the other leg, swing it to the side Upper side and down. And now stand put on one leg and bring the upper foot in front and back. And the other leg, bring the foot in front and back. And now bring one leg up, breathe in. Out the leg to the side. Again in. Breathe again out, leg in and down. So breathe in. Breathe out, leg to the side. Breathe in. Out, leg into the middle, and again down. And now bring one leg up and the hands out, and go with the hands out to one side. With the hands over to the other side. Into the middle, and now we have the hands over to one side and with the leg over to the other side. And change. Into the middle and down. Other leg up and go with the hands over to one side. And to the other side. And change. Go across on with both. And change. And now one leg up. And press with the knee up and to the side. And with the other one, press up and to the side. And now this exercise can go onto the knee. Stand good. Turn over to the one leg. Go down into the knee. Turn over to the other side. And come up again. And again. Stand good. Turn over to the leg. Go down. Turn to the other side. And go up. Other side. Stand good. Turn over to the leg. Go down. Turn to the other side. And come up. Stand again good. Turn over to the leg. Go down. Turn to the other side. And come up. And now the next exercise, this can go again onto the knee. Stand good on one leg and go always to 90-minute intervals on an imaginary dial, and the knee goes always a bit down. And now with the other leg. 1:30 and 3, and 10:30 and 9, and 7:30 to 6, and also 4:30 and again 3. Now one hand on tummy, one on lower back, and lift one leg in a straight line up with a flexed foot. If a quad muscle is cramped, then pull the leg up. Try to bring the leg higher. Control with the hands that you don't hold back. And pull the leg up, point with the toes down and relax the leg. And on the other side. Stand good and bring the leg up. Flex foot and try to bring the leg higher up. Control with the hands but you don't fall back. And pull the leg up and point with the toes down and relax the leg. And to the next exercise. The next exercise, one foot points to the outside, the other heel is on the ground. Do this down, do this exercise if you're pregnant, and lift the heel off the ground, place it again on the ground, and continue with it. And on the other side, heel onto the ground, lift that heel off the ground, and place it again on the ground. And the next exercise, foot up and again down. And on the other side, foot up and down. And now, one leg in, and again out, in and out. And over to the next exercise, if you like, also the whole body comes now up and down. And the other side. First leg in and out. And now if you like the whole body. One more time. And ending the closing exercise, legs wide apart, breathing around. And breathe out. Again in. Out. Breathe in and close the legs. And breathe again out. That was the leg injury prevention training. I thank you very much and until next time.